Hey everybody, Rhett from TorchPrep here, talking about math test number 4 out of the red book, question number 48. So go ahead and pause the video now and find question number 48 from math test 4. All right, so you're on question number 48. You're taking a look at this question. This is getting in the deep into the back half of this test, which we know there are harder questions on the back half typically than the front half. We know that the questions don't immediately go in a direct line of difficulty, but we're getting into some of the more difficult questions. As we look at this is an interesting style question. One of the things I want you to always think about, anytime you can draw a picture, you want to draw a picture. So they tell us that there are three side lengths of a given triangle. And it's 4, 5, and 7. So I'm just going to draw any old triangle I can find and think about. It could have looked much different than this. I just made it up. This may not even be what it looks like, but I'm just trying to get an idea. Let's call this 4, 5, and 7. Obviously, this is the longest side, so I'm making it 7. It could have looked very different. I don't know if this is what the triangle looks like. I'm just getting an image to start working with for this question. Ultimately, what they're asking is deciding the classifications of this triangle. Okay? So if you look at this, it says, which of the following descriptions best classifies this particular triangle? Scalene acute, scalene right, scalene obtuse, isosceles obtuse, isosceles right. Well, there's no just like pure, no human probably that I know of can just look at this and go, which one of these it is. You have to do some process of elimination and begin to unpack all of your years of study of geometry and what you know about triangles. So one of the things I like to look at here is two of these options are right triangles, right? Option G and option K. Now, we have to look at this and go, we can look and go, well, did I draw it like a right triangle? Well, maybe it looks like a right triangle, maybe it doesn't, but we have to be able to prove whether it is or is not a right triangle. So I think that it's probably easiest of all the types of classifications to say whether something is or is not right. Okay, a right triangle. Is there a right angle here? Well, one of the things we know about right triangles is that if all of the side lengths are whole numbers, they should represent one of the Pythagorean triples that we know. Well, the two smallest Pythagorean triples are a 3, 4, 5 triangle or a 5, 12, 13 triangle. Neither of those are this triangle. So guess what? We immediately know that option G and option K are incorrect. So G, no. K, no. Now we've got 3 options left. Again, I'm just using process elimination here. J is interesting. What do we know about isosceles triangles? Isosceles triangles. Isosceles triangles have 2 sides that are the same length, congruent, right? They also have 2 angles that are congruent. This triangle, according to the measures they gave us, does not have 2 side lengths that are the same measure. So guess what other option we can take off? Option J. So we've now eliminated 3 of the 5 options, okay? So we've eliminated 3, we have 2 left. So the only 2 left are deciding whether it is a scalene acute or a scalene obtuse. Now, this is testing your ability to remember all of these classifications. What does scalene mean? Scalene means all the side lengths are different. So you could have done this question differently and said, what does scalene mean to start? How you enter the problem is up to you, really. But we know that it's a scalene because all 3 of these are different. So really now all we're determining is it acute, which means all 3 angles are less than 90 degrees, right? That's what acute triangle means. Or is it obtuse? Obtuse means one of the 3 angles has to be greater than 90 degrees. We always know that the sum of all the interior angles of a triangle must be 180, but for an obtuse, 1 angle greater than 90. For an acute, all 3 must be less than 90. So that's what we're working with here. We have to make the determination for those 2 classifications. So the question is, how are we going to do that? Well, there is a potentially little known, I don't know if trick is the word, but we can use the Pythagorean theorem not just to find side lengths in right triangles, but you can have, there are other uses. One of the uses for the Pythagorean theorem is to determine whether the side lengths of a triangle make the triangle an acute triangle or an obtuse. And I'm going to show you what we mean. So we're going to plug these in as if they were representing a right triangle, even though we know they're not. And it's going to show us whether it's acute or obtuse. So here we go. The two legs of a right triangle, if this were a right triangle, would be 4 squared plus 5 squared. There's some, I'm going to leave a box here. That is a horrible box. Oh my gosh. I don't know. It's not equal to. If it were equal to, it would be a right triangle. But it's going to either be greater than or less than. This would be less than, that's greater than. Okay? 7 squared. So we basically need to see, when we fill this in, which one of these it is. If it's less than, all right, if these two are less than, the sum of these is less than that, then it's going to be obtuse, okay? If it's greater than, it's going to be acute. Now this is kind of just something that you got to know, right? It's one of those things, it's like that you got to have the knowledge that this is how you would determine acuteness or obtuseness of a triangle. All right, so we do this, 4 squared plus 5 squared, that is 16 plus 25, okay? 7 squared is, I'll write this over here so it's a little more visible. So 4 squared is 16 plus 25. I don't know what I'm filling in yet. 49. Well, this is 41. This side's 49. It's less than, which means, according to my rule, it must be an obtuse triangle. And the answer is H.